Hey everyone. In this video, we're going to be talking about Dalton's law of partial pressures. Now, this concept basically is stating that the total pressure of a gas sample is equal to the individual pressures of all the gases in a mixture. So as an example, if you had a helium tank with 2 atmospheres worth of pressure of helium and another tank of argon with 4 atmospheres of pressure, if you were to combine these gases into a single tank, the pressure in this tank would be 2 atmospheres plus 4 atmospheres for a total of 6 atmospheres. So the total pressure of a gas mixture is equal to the partial pressures of the individual gases that make it up. Now, the air that we breathe, right, just the air on Earth, is actually a mixture. And this chart is showing the composition of gases in that mixture. There's 3 columns here. This is the air that you're breathing. This is air inside your lungs, and then this is air that you exhale. And so air that you breathe is about 594 millimeters of mercury nitrogen. Only about 160 are oxygen. Carbon dioxide is 0.3 millimeters of mercury, and water vapor in the atmosphere varies from region to region, but on average, it's about 5.7 millimeters of mercury. Now, inside your lungs, those ratios are a little different. There's a little bit more carbon dioxide. There's a lot more water vapor inside your lungs. There's a little bit less oxygen and a little less nitrogen. And then air that you exhale is going to have slightly different ratios. But notice that the totals are all the same. Okay. And so the total pressure is equal to the individual pressures added up. And these ratios can be different, but as long as you have the same total moles of gas, you're going to have the same total pressure. Let's do a study check. A scuba tank contains oxygen with a pressure of 0.45 atmospheres and helium at 855 millimeters of mercury. What is the total pressure in millimeters of mercury in the tank? So we know that pressure total is equal to the pressure of the oxygen plus the pressure of the helium. Now, the problem here is that the oxygen pressure is given in atmospheres and the helium pressure is given in millimeters of mercury. Those are different units, so we can't add them together the way they are. We're going to have to convert the oxygen pressure into millimeters of mercury first. So 0.45 atmospheres. And we know that there's 760 millimeters of mercury per 1 atmosphere. Atmospheres cancels. So 0.45 times 760 gives you about 342 millimeters of mercury. Now we can use that in our equation. So P total is equal to the pressure of the oxygen we just solved for is 342 millimeters of mercury, plus the pressure of the helium, which is given at 855 millimeters of mercury. So the total pressure is going to be 1197 millimeters of mercury. And if you round that to 2 sig figs or 3 sig figs, like 1200. Okay, another practice. For a deep dive, a scuba diver uses a mixture of helium and oxygen with a pressure of 8 atmospheres. A if the oxygen has a partial pressure of 1280 millimeters of mercury, what is the partial pressure of the helium? So once again, they gave us these in different units just to be annoying. So let's convert atmospheres into millimeters of mercury again. So 8 atmospheres times 760 millimeters of mercury per every 1 atmosphere. So 8 times 760 would be 6080 millimeters of mercury. So our overall equation is pressure total equals the pressure of the oxygen plus the pressure of the helium. They tell us the total pressure is 8 atmospheres or 6080 millimeters of mercury. The pressure of the oxygen is 1280. And what we don't know is the partial pressure of the helium. So if we're trying to solve for this, we got to subtract 1280 from both sides. So the pressure of the helium should be equal to 6080 minus 1280, about 4,800 millimeters of mercury. Looks like we did it right. So to recap this video, we're looking at Dalton's law of partial pressures. And the equation here is the total pressure in a gas mixture is equal to the individual pressures of each of the gases within that mixture. Thanks for watching, and I will see you in class on Tuesday.